Good morning or good afternoon, my YouTube viewers. It's Crystal here. I'm just here because I wanted to do another code review for you. This is the second video that I've made because I was working through the video and I got a phone call and I had to stop to take the phone call. And so my technology is not that great, so I had to stop the video, and which means I have to start it all over again. So what we're going to do is we're going to do a house price competition, which is a community competition with Kaggle. I've done several house price competitions in the past, but I decided I'd go ahead and try it this one and see if I could get a good score, see what would happen if I could get a good score. So this is a community competition with Kaggle. I'm using Tensorflow, a sequential model, and what I will do is I will leave a link to the Jupyter notebook in the description box down below. And I tried several models. I tried a functional model. I used a sequential model and a functional model, and the sequential model worked best. I tried several different methods to try to improve my score, but this method that I'm using right now was the best score that I could get. So what we'll do is I just want to make sure I've got the best one. So we'll come over here and we'll check my submissions. And okay, so this was my public score, 71. So there we go. So this is it. So this was my best score, and so this is the Jupyter notebook that I'm using. So the first thing we want to do is we want to look at the problem statement. And the problem statement is find the value of a house in US dollars. That's the problem statement. So this is a regression problem. And I tried several different alternatives to improve the score, and this was the best score I could get. So first thing we're going to do is we're going to import NumPy as MP, which creates your NumPy arrays and performs numerical computations. We're going to import pandas as PD, which creates your data frames and your series and processes the data. We're going to import OS, which goes into the operating system, and it's going to retrieve the files that we're going to need to work on. We're going to import sklearn, which provides machine learning functionality. We're going to import SciPy, which performs statistical tests. We're going to import TensorFlow, which provides your neural network. We're going to import matplotlib.pyplot as PLT, which visualizes the data. And we're going to import Seaborn as SNS, which statistically visualizes the data. So you can see that on TensorFlow, we're using version 2.12. And the thing about TensorFlow is it goes through lots of changes. And so you need to be familiar with the version of TensorFlow that you are working on, because if you're working on a different version of TensorFlow, you could be working with deprecated functions and things like that. So it's always a good idea to know what version of TensorFlow you're working on. So after we have imported the libraries that we're going to need to work on the problem, we're going to use the OS library to go into the system and retrieve the files that we're going to need. The 3 files that we're going to be using are CSV files, and they're train, test, and sample submission. So after we have imported those files, then what we're going to do is we're going to use pandas to convert the files to data frames. And so the 3 data frames that we have are train, test, and submission. So you can see train is here, and it's 23,634 rows by 14 columns. The last column is the price, and so that is your target. And then we checked for any null values. We didn't have any null values, and so that was good. So that meant that we didn't need to impute any data, which is good. Now we're going to check the test file, which is 2627 rows by 13 columns. It's got the same number of columns that are in the train file, except for the fact that it doesn't have the price, because that's what we're going to be predicting on. We checked for null values. We don't have any null values, so that's good. Nothing to impute. Now we check submission. This is what Kaggle wants to see when we submit our work. The next thing we're going to do is we're going to check the number of unique values in the columns of data. And you can see that because I just wanted to see how many unique values you had in each column of data that was an object. So we can try it out and see what we got. And we tested the same. We did the same thing with the test, so you can see how many unique values we have in the test set if it's an object. Now what we're going to do is we're going to analyze the target, and target equals train.pop price. So we're going to pop the price out of the data frame. Excuse me. And then when we pop the price out, then the train and the test sets will be of the same format. And then what I've done is I've created a histogram of the target. And so you can see the histogram of the target, and you can see that it's skewed a bit. So now what we're going to do is we're going to analyze the training data, created a box plot. So we did a box plot on the home type, so you could see the prices between the single family, condo, townhouse, and multifamily. So it looks to me like the multifamily is just slightly more money than a single family house. We also wanted to see the price of the houses according to the states. So you can see that some of the states have a higher price than others. So I think California is one state, New York is one state, and they've got other states as well, but it's a little bit more difficult for me to determine that on this box plot. But I suppose that if I really wanted to know what the values of each state were, I could do a pivot table on the states, and then when you do a pivot table on the states, or a group by, I could do a group by on the states, and then the group by on the state, you could get the mean of the price, and that would tell you the mean of the price. But obviously I didn't do that in this one. But if you're really interested in knowing the price of a state, that's a good way to do it. Group by on the state, and then to get a mean of the price. Or the next thing that we did was we did a box plot on the home status, and so you can see recently sold and pending are very similar, with the exception that recently sold has got some outliers. We're going to check between the lot unit, whether it's a square foot or acres, and you can see that the square foot and the acres are very similar, with the exception that the acres have got some outliers. Now we're going to check bedrooms, so you can see the maximum number of bedrooms. So it looks like the 12, if you've got 12 bedrooms, then it's going to be a higher price than anything else. And like a 1 bedroom is going to be a lower price. So that's pretty self-explanatory, is the more bedrooms you have, the higher price you're going to get. Now we're going to check bathrooms. So you can see, obviously, the more bathrooms you have, the higher price you're going to get. Like this one, I think it had like 7 bathrooms, was higher than an 8. But it's pretty self-explanatory that if you only have 1 bathroom, the price is going to be less than if you have more than 1 bathroom. But that just gives you a box plot. We did a scatter plot of living area. So you can see that the greater the living area, the greater the price is going to be. And also we've got some outliers there as well. So now what we did was we just checked scipy.stats, and we did a Kolmogorov-Smirnov test to see if any of the columns don't come from the same distribution. So we can see that lot area doesn't come from the same distribution. And then we're going to delete ID, city, address, and date sold. I suppose possibly we could have left date sold in there, but date sold was in a scientific notation number, so I just deleted the date sold. But I suppose we could have used date sold. We would have had to have encoded it, but I suppose we could have done that if we wanted to. But I didn't use date sold in this instance. So if you want to try to use date sold to get a higher accuracy or a lower error, you can always try that. So now what we're going to do is we're going to encode the object columns. And so with train, we're going to use the sklearn's ordinal encoder. And with train, we're going to transform each column that's an object. And with test, we're going to transform it. We're going to use Seaborn to create a heat map, and you can see we've got a heat map here, and you can see from the heat map you don't have any columns that are really highly correlated. But you can see the correlation here if you want to see the correlation, but none of the columns are highly correlated. And then what I did was I checked to see here in this code here to see if there were any columns that had a correlation of greater than 95%, and there were no columns that had a correlation of greater than 95%. And then now what we're going to do is we're going to use sklearn to standardize the data, and I'm going to use min-max scalar in this instance. So scalar equals min-max scalar. And then so for every column on the train data set, we're going to use scalar.fit transform, and then the train column .values.reshape -1, 1, and then on test it's going to be just the transform. Now we establish our x and our y variables. Those are your dependent and your independent variables. So y is your target, x is your train, which is independent, and x test is your test, which is independent. So now what we're going to do is we're going to use sklearn to split the data set up into training and testing, training and validation sets. Test size is going to be 0.1, random state is going to be 42, and so you can see that we have 9 columns of data for the train and the test sets. Now we're getting into the neural network part of the program, where we're going to use Tensorflow. So we import the Tensorflow modules that we're going to need to input the data to make predictions on the data. And now what I do is I define a sequential model and I compile it. And so in this particular instance, I used 64 neurons for the hidden layer 1 and hidden layer 2. Hidden layer 3, we use 32 neurons. And in the output layer, we're using 1 neuron because it's a regression problem and it's linear. And with the compile of the loss, we're going to use the mean squared error, and the optimizer is Atom. Could have also used RMS prop if you wanted to, because that gives good results as well. And then this is the summary of the neural network that we have created. Now, after we've compiled the data, which we compiled it here, we compiled it right here with the mean squared error and the Atom. If you want to try RMS prop to see if you can get a better rate, you can always try that. Then what we did is we trained the data. So we set it up for early stopping and model checkpoint. And so history equals model.fit, x train, y train, epochs equals 400, validation data equals x val, y val, batch size equals 32, and callbacks are early stopping and MC. One thing that I will say is I used 400 epochs and it still didn't go into early stopping. So in order to improve your score, you might want to try 500 epochs and see if the score will improve if you have 500 epochs, because it didn't stop early with the 400 epochs. So we go all the way down here to 400 epochs, which I could have done 500, but I just decided not to. But if you want to try to improve the score, you can put it on 500 epochs and see what happens. And so now what we do is we create a graph, and you can see the loss. The val MAE is a straight line, and the val loss is your green, and your loss is your blue. So you can see the loss there. So now what we're going to do is we're going to predict on the validation set. And we're going to get the root mean squared error. Root mean squared error is 97,605. We're going to plot this using matplotlib, and you can see now there's a possibility if you had more epochs, like maybe 500, there's a possibility that the actual values would fit better on the predicted values. I created a data frame that had the actual values and the predicted values, and then I predicted on the test set. And after I made predictions on the test set, I prepared my submission. So submission price equals pred, submission.toCSV is submission.csv, index equals false. So what we did was we took submission and we converted it. We made it a CSV file. Submission equals PD read CSV. So we read the CSV file, and this is the CSV file. And then what we did when we finished it, and you can see when we finished it, you go to output, and then when you go to output, you click over here on submission, and then when you click on the submission, you can submit your work to Kaggle, and Kaggle will score it. So because basically what I had was a message this morning, somebody asking me, how do you get an output and how do you submit your work? And so what I did was, rather than put a response in the reply, I made a video on how to get the output and how to submit your work. But if you have any other questions that you would like me to make a video on, then please let me know. And that would be a good thing for me to do, is to answer the questions that people have in video format. So that would be a good project for me to do. So I'm going to go ahead and conclude this video because I've talked about it as much as I possibly can, and I've given you all the information that I could and told you things that you can do to improve the score if you want to. So thank you so much for my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you again for watching my video. I look forward to making more videos for you in the future.